Good morning, students. Yesterday you did Rolle's theorem and today we will learn about Lagrange's mean value theorem. Lagrange was a mathematician and the theorem which he gave is known as Lagrange mean value theorem or simply mean value theorem. According to this theorem, if a function f from closed interval ab to r is such that it is continuous in the closed interval AB and it is derivable in the open interval AB, then there exists at least one value C belonging to the open interval AB such that f dash C is equal to FB minus FA over B minus A. It is same as Rolle's theorem, but the only difference is that in Rolle's theorem there were three conditions, but here there are two conditions, and the first two conditions, these two conditions are similar as the first two conditions of Rolle's theorem. Clear? There is no third condition. And if these two conditions hold, then there exists at least one C such that f dash C is not 0, it is FB minus FA over B minus A. And in question form, how it will be asked? Verify mean value theorem if fx is equal to x square minus 4x minus 3 in closed interval 1, 4. You have to verify mean value theorem. So, fx is given to you. Being a polynomial, yesterday I told you that this is a polynomial function. So, being a polynomial function, it is continuous because every polynomial function is continuous on the set of real numbers. So this is also a polynomial function. It will be continuous in the closed interval 1, 4. Now f dash x is equal to 2x minus 4. And if we talk about the open interval 1, 4, then it is derivable in the open interval 1, 4. Clear? So by Lagrange's theorem, there exists at least one C belonging to this such that f dash C is equal to f4 minus f1 over 4 minus 1. Now what is f dash C? It is 2C minus 4, right? So f4, if you will calculate value of f4, it will be minus 3, f1 it will be 6. So 6 minus 3 by 3, 3 by 3 is 1. So C is equal to 5 by 2, it means it is 2.5, and 2.5 belongs to the open interval 1, 4. Hence mean value theorem is verified. Clear? So it is same as you did for Rolle's theorem. Now second question is, examine the applicability of mean value theorem for the function fx is equal to gent x. This question is same as you did for Rolle's theorem, and here it is same, fx is gent x for x belonging to, and the interval is minus 2 to 2. Now we will check the two conditions. First condition is we have to see whether this function is continuous for this closed interval. So firstly we will check the continuity. Now suppose we check its continuity at x is equal to 1 because 1 is the point inside this interval. So let us check its continuity at x is equal to 1. For checking the continuity, firstly we check whether limit x going to 1 exists. So limit x going to 1 minus means left hand limit we will take, and when we will keep it x going to 1 minus. So when this will enter in gent, it will be suppose it is 0.9, so its value will be 0, and limit x going to 1 plus means when we will calculate right hand limit, it will be, suppose it is 1.1, so its value will be 1. Now left hand limit is not equal to right hand limit. It means limit x going to 1 fx doesn't exist, and in fact this limit does not exist at all integral values. That is, suppose in this interval now all integral values are minus 2, minus 1, 0, 1, 2, and at all these 5 points this limit doesn't exist. And if the limit will not exist, we will not talk about its continuity. So fx is not continuous. Clear? It means the first condition doesn't hold. It means mean value theorem is not applicable. So this was all about mean value theorem. Clear? In mean value theorem there are 2 conditions. In role theorem there were 3 conditions. So today we have completed our chapter 5, differentiability. Thank you.